All right, so we want to do a video on a hypothesis test on a mean when the population standard deviation is known. So I'm going to try to make a video for, each of the different situations that you're going to come across. We'll do a hypothesis test for means when sigma is known. We'll make a video on a hypothesis test for means when sigma is unknown and we have to use a t statistic instead of a z statistic. We will try to cover all the different cases of the alternative, right? The alternative can either be greater than what we think going in, as in this case, we'll get to this, or less than what we think going in, or if we don't know, we call it a two-sided alternative, where we're just looking for any difference from what we think going in. So keep in mind the trial by jury example. Innocence is the null hypothesis that you go into the test with. You look at evidence. If the evidence suggests otherwise, then you reject that null hypothesis in favor of the alternative. So here, we're looking at this situation here. We have a veterinarian taking glucose readings from a horse and getting a mean of 93.8 from 8 readings. Now, this is a very small sample, so we have to assume that the glucose readings follow a normal distribution, right, because of that small sample size. But we will assume that. We will assume that the glucose readings of all horses, or at least horses of this type, follow a normal distribution, and we're going to assume that we know the population standard deviation here of 12.5. All right, we go into the test thinking that the mean glucose reading should be 85. That's our null hypothesis. The readings for horses of this type, average mean glucose reading should be around 85. So we took 8 readings from this one horse over some period of time and got an average of 93.8. So we're going to test the hypothesis that the horse whose levels were measured, this horse, 8 times, 93.8 was the average. We're going to test the hypothesis that those are higher than what it should be, or what we think going into the test, of 85. And we're going to use a significance level of 0.05, meaning 95% confidence, or that level of evidence. So just like every hypothesis test, we go through the 4 steps. So gather the information first, right? That's always the first thing to do. You got your sample size, you have your null hypothesis, the value of the mean going into the test. What we think the mean is going into the test is 85. We take a sample, we take samples, 8 samples, and we get an average. We take a sample of 8 readings and we get an average of 93.8. We're using an alpha level of 0.05. It's one-sided because we're looking for evidence that the horse that we measured is higher. If we wanted to show that it was lower, then we would call that a one-sided to the left. Okay, this is a one-sided to the right because we're looking for evidence that the mean glucose level is higher than what we think. So we go into the test assuming that the unknown population parameter is equal to 85. We are looking for evidence that that unknown population parameter is more than 85. We're using an alpha level of 0.05, and we call it a one-sided to the right test. This is a one-sided test. We're looking for evidence that it's higher than 85. Well, we have all the information, which allows us to form our z statistic. Our second step is to form the z statistic, and we're using a z statistic because we know the population standard deviation. This is a rather unreasonable thing to know. We don't usually know what that is, but we're in a classroom, so we're using examples that we know the population standard deviation. If we don't know the population standard deviation, then this becomes a t-test statistic, and we use the t-tables to find our probabilities in step 3. But for now, we do know the population standard deviation, so we form our z-test statistic with this formula, the sample mean minus the hypothesized value divided by the standard deviation, or what we sometimes call the standard error of the sampling distribution of that sample mean. We have all those values, the sample mean, the hypothesized mean, the population standard deviation, the square root of the sample size. You calculate that number, you round it to 2 decimals, right? Remember, z values you round to 2 decimals because that's the way the table is set up. If it's a t value, you're going to round that to 1 decimal because that's the way the table is set up. So you want to get these details straight. We round our z value to 2 decimals, we get 1.99. Again, remember what that says. That says that our value is almost 2 standard deviations away from the center of a sampling distribution where this is the true mean. If this is the true mean, then this is the center of the sampling distribution. So if this is true, we got a value almost 2 standard deviations away from that. Well, what does that tell us about the probability that this is true? It's the next step. The p-value is the probability that we get. The p-value is the probability that if this is true, what's the probability that we got something that far away from what we thought, right? And if that probability is low, then that leads us to believe, well, maybe our null hypothesis is not true. Maybe we should go with the alternative. That's the whole logic of the idea. That's where you want to read that section in the other video where we went over the hypothesis tests to get the kind of the theory of what's going on. So if this is true, why did we get a value that's almost 2 standard deviations away from that center? Well, what is that probability? That's what step 3 is. What's the probability that we get a value greater than this, greater than or equal to, remember, doesn't matter in a continuous distribution. What's the probability that we get something this far away if this is true? Well, that's where we go to the table and we say, what's the probability of getting a z value greater than 1.99? We know how to find values in our standard normal table. For greater than, remember, we can use the idea of complements and say 1 minus the probability that z is less than this number. Or in this case, I use the symmetry method. And because 0 is in the middle of the standard normal distribution, we know the probability to the right of positive 1.99 is the same as the probability to the left or below the negative of that value, or negative 1.99. So in this case, all we got to do is look up negative 1.99 in the table. We get this value. So what this tells us, what this p-value tells us, is that if this is true, if the idea going into the test is true, we're going to get a value this far away from that only 2.33% of the time. Right? So pretty low. And now, depending on your level of significance, you're going to make a conclusion now. Okay, so 0.233, if we use an alpha level of 0.05, the only condition is if the p-value is less than alpha, which it is, right? Our p-value is less than alpha, we reject that null hypothesis and say there is sufficient evidence to suggest that that horse's glucose level is higher than 85, the alternative hypothesis. Right? Now, if our alpha level was 0.01 and we required even more evidence, the lower the significance level, the more evidence we require to reject the null hypothesis. If this was 0.01, well, this is not less than 0.01. So at a 0.01 significance level, we would not have rejected. We would have stayed with the null hypothesis. But at an alpha level of 0.05, we do satisfy the condition to reject the null hypothesis. So 4 steps every time, 4 steps for these hypothesis tests. Gather the information and then start your steps. Form the hypothesis, and I want this to be done correctly. Don't say the null hypothesis equals This, it doesn't equal that, it's a statement. So put a colon there, right? It's a statement. The null hypothesis, this is the statement that the unknown population parameter equals some value that we think going into the test. We are looking for evidence, the alternative, we're looking for evidence that that unknown population parameter is greater than what we think. We determine a significance level, we label it as two-sided or one-sided, either to the left or right, depending on what we're looking for. We calculate the z-test statistic using this formula. We come up with that z-test statistic. We find the probability that, in this case, to the right, that our z-value is greater than that z-test statistic. We look that value up in the table. We get a number. We compare it to our alpha level, and we make a conclusion based on that p-value and the alpha level. If the p-value is less than alpha, we reject the null hypothesis and say there is sufficient evidence to suggest the alternative. If the p-value is greater than alpha, then we do not have enough evidence to suggest anything other than what we thought going into the test. All right, so that's our first example of a hypothesis test. It was a test for a mean when sigma was known. Our next video will be a hypothesis test for means when sigma is unknown. See you then.